What letter are we dealing with first? Are we dealing with X or are we dealing with Y? So when we observe the first two questions which I have solved in this session, so we dealt with X. So let us shift our idea into dealing with Y now. Now, since I'm dealing with Y now, the very first thing I have to do is to determine what are the coefficients of Y's in this question. So we can see the coefficient of Y here rather is 1. And coefficient of Y here is as well 1. So remember, in the first two questions I dealt with, I concentrated on the coefficient of X all because my focus was on dealing with X first. But this time around, that has shifted a little bit, all because we are interested in Y. So whatever letter you are interested in first, or that you are concentrating on first, our point is going to be on the coefficient of such a letter. So in this case, I'm not interested in the coefficient of X, but interested in the coefficient of Y, since my focus is on what? On the letter Y. Now, what are the coefficients of Y? So we can see coefficient of Y here is 1, coefficient of Y here is 1. So once the coefficient is the same thing, then the next thing is we move straight into the rule which we want to apply. Now, which rule? The rule that will enable those two Y to cancel each other. So is it when I say Y plus Y that they will cancel each other, or when I say Y minus Y that they will cancel each other? So common sense will prove to us there that it's only when I subtract. So in equation 1, I have Y. In equation 2, I have Y. And by the rule of elimination method, we want these two Y to become 0. And we have only two options in dealing with that, either by adding or by subtracting. Is it when I say Y plus Y that I will get 0? We can see that one is not. It's not, because Y plus Y gives what? 2Y. So this one will not work. When I say Y minus Y, will that give 0? Yes. And this is one of those things elimination method is preaching. So as a result, we are going to subtract. So I can subtract. After putting this my minus sign, then I can rule below it like this. Now what will happen now is I'm going to say everything I have in equation 1 minus everything I have in equation 2. But it has order. The order for doing that is I must finish everything related to X before moving over to everything related to Y, then everything related to what? To numbers. So in this case, I'm going to say that 2x minus x. Now I've done everything X. I will move over to Y. So something related to what I have here is plus Y. I will now say minus, since I'm subtracting. Minus what? Minus. What I have below here is plus Y, then is equal to 7 minus 5. Now 2x minus x here gives x. Now here is plus Y, so we can see minus followed by plus. That simply means minus times plus, which gives minus Y is equal to 7 minus 5 here gives what? 2. Right? Now with this, we can see why we cancel the other Y. And we are now left with x is equal to what? 2. So that shows x values in this equation is what? 2. Now to get the Y value, what I will do is I will make reference to one of these two equations. That is, I will copy one of these two equations outside here. So let me go for equation 2. So any equation can be used. Even after I use equation 1, someone else solving it use equation. I'm using equation 2, someone else use equation 1. We are still going to get the same result once we apply the correct algebra. Now, so I will say that x plus y is equal to what? 5. Now, in this place now, I'm free to call x 2 because x is defined as 2 here, or value of 2 is obtained for x here. So in this place, I will say 2 plus y is equal to what? Is equal to 5. Hope you remember the reason why I'm changing this x as 2. Remember, I'm looking for the value of y, and I cannot deal with x and y at the same time. So that's the reason why y will have to be obtained first. We substitute the value we obtain for x, in order to be able to get the value for y. And 2 plus y here is 5 simply means I can say y is 5 minus 2. So 5 minus 2 there gives 3. So it shows y is equal to 3. So that means I'm done with the third example. Then I can now summarize the whole thing which I have on the board by saying that therefore x is equal to 2, y is equal to 3. And that also completes our third question. We are going to solve 2 more questions since time will still permit me. Let me solve 2 more questions and I can call it a day on the elimination method. And the next session we'll be discussing the substitution method of solving the simultaneous equation. Now let's solve these 2 equations and we'll call it a day. Now, number 1, I can write it as 2x plus 5y is equal to 1 and name it equation 1. 3x minus 2y is equal to 30 to be named equation 2. Right? Now, like I said in the previous 3 examples, so I said the first step to dealing with this question is to pick a letter we want to deal with. Is it x we are dealing with or is it y? So I will love dealing with x in this case. Now that I know I'm dealing with x, then the next thing is let's look for the coefficient of x in the first equation as well as the second equation. So we can see here coefficient of x is 2, while here coefficient of x is 3, which is different from those first 3 questions which we have solved. So this case here, coefficient needs to be the same before we can eliminate. Once the coefficients are not the same, elimination method cannot be used, right? But it is still elimination method we want to use. So in order to use the elimination method, an adjustment will have to be what? To be carried out. How do we carry out the adjustment? So it is very simple. What I will just do in that case, since all I am interested in is to make sure this x, 2x I have here contain the same coefficient. So in order to make it balance, what I will do is coefficient of x in equation 2, I will move it upward. And coefficient of x in equation 1, I will move it downward like this. And without the in between this number and my equation 1 will be multiplication sign. In between this newly introduced number and the rest of equation 2 will also be multiplication sign. So since I have multiplication sign, this 3 here will now multiply everything in equation 1. Same thing happen here. These 2 I have here will multiply everything in the second equation. Now, 3 times 2x is 6x. 3 times 5y is 15y. And 3 times 1 here is 3. So that now becomes another equation, which is equation 3. Then we do the same thing. 2 times 3x is equal to 6x minus 2 times 3y that is 6y, which is equal to 2 times 30 here is 60. So we can call this or name this equation 4. So with these little adjustments that happened here, so we can see that x we devote our attention or now contain the same coefficients. Once they contain the same coefficient, then the next step of action is to ensure this cancel this. Now I have 6x in first equation. I now have 6x in the second equation. And by the rule of elimination method, we want this and this to become 0. And we have two operators we can use, only plus and minus. Oh, when I try plus, when I say 6 plus 6, can this give 0? We can see that is not possible. What if we use minus? Can 6x minus 6x give 0? We can say it is yes. Therefore, I'm going to subtract the whole of equation 2 from the whole of equation 1. So let me rule it below, from below like this. So here I can now write it as 6x minus 6x plus 15y minus minus 6. Now here should be y. Minus minus 6y is equal to 3 minus 60. So we can see this cancel this. So I'm left here with 15y plus, because minus as minus gives plus. 15y plus 6y here is equal to 3 minus 60 here gives minus 57. Now there is a mistake somewhere. Where I carried out my multiplication, 2 times 3x is 6x, y 2 times 2y should be 4y. So where I have 6y should be changed to 4y. I'm sorry about that. Now 15 plus 4 is what? Minus minus becomes a plus 4y. So it is balanced now. 15y plus 4y here, 19y is equal to minus 57. So to get my y here, I will divide both sides by 19. So you can see this cancel this. So that shows y is equal to, and we can see 19 and 57 will be 3. So that will be 3, but it contains negative sign. Y is minus 3. So to get my x here, what I will simply do is to copy any of the any one out of the 4 equations. But let me copy equation 1, or let me reference equation 1. So what is equation 1 originally? It is 2x plus 5y is equal to 1. Since I obtained the value of y to be minus 3, anywhere I come across y in this reference equation, I will just put the value of minus 3 there. So here we say 2x plus 5 times minus 3 is equal to what? Is equal to 1. Here we can say 2x plus times minus here gives minus 5 times 3, 15 here is equal to what? 1. And I can say that 2x is equal to 1 plus 15. And that gives 2x is equal to what? 16. So to get my x here, I will just divide both sides by what? 2. And let's give the value of what? 8. So that one also completes the whole stuff. But I also want to do what? To summarize the whole solutions on the board. I can summarize it now by saying that therefore x is equal to 8 and y is equal to minus 3. This one as well renders or gives the complete solution to our fourth example, or under the example 2, fourth question, but first question under example 2. Now, finally, before we close the session, so a plus 2b is equal to 13. I can name that equation 1. 2a minus 3b is equal to 5. That can be named equation 2. So we also need to concentrate. Are we dealing with A or are we dealing with B? So since this is the first two sessions of this topic, let me still go with the letter A. That is the first letter I have in the two given equations. So I'm going for A now. Now, since my focus is on A, then the first thing I need to know now is what are the coefficients of A in both equations. So we can see coefficient of A in first equation is 1, while coefficient of A in the second equation is what? 2. And by the game or by the rule of elimination method, the two coefficients are supposed to be the same thing. Once they are different, right, that means we are going to carry out a particular adjustment. And what is that adjustment? The adjustment is simply, since all we want this and this to rhyme, to look alike, to be the same thing, right? It simply shows that the number I have, the coefficient of A in equation 2 will be moved to equation 1, while the coefficient of A in equation 1 will also be exchanged in the second equation. And we write them in such a manner that they multiply every other thing we have in those two equations. So that simply means I will say 2 times, since coefficient in equation 2 is 2, I will bring it up here. While coefficient of A here is 1, so I will introduce that one to everything in equation 2, having multiplications. And remember, when those two coefficients are interchanged like this, they will connect with what we have in those two equations by way of what? Multiplication. Now, let's now multiply them out to obtain two fresh equations. So 2 times A here gives 2A, 2 times 2b here gives 4b is equal to 2 times 13, 26. We are now going to name this new one equation 3. And the other way around, 1 times 2a is 2a, 1 times 3b is 3b, 1 times 5 is equal to 5. Here we have two options, is equal to 5 rather. I can call it equation, okay, let me call it equation 4. Don't let me use any option here. I can call it equation 4. Let me call it equation 4. Now, the next thing is, then we now want to carry out the real elimination. The real elimination happens where we have the same coefficients, and that is in front of A here. Now, in equation 1, I have 2A. In equation 2, I have 2A. Look at it, 2A and 2A. But by elimination, we want these two to combine and become 0. And we have two options in doing that, either by adding or by subtracting. Now, when I say 2A plus 2A, can that give 0? Common sense tells us that that is not possible. But what if I say minus? 2A minus 2A becomes 0. So that shows we are going to subtract. So I will rule below it now and go ahead with what we have here. And mind you, we are going to deal with A first before we move over to B and before we move over to the number part, right? So the first thing I'm going to do here is to simply say 2A minus 2A, followed by plus 4B minus 3B is equal to 26 minus 5. Right? So with this thing I have here, this will cancel this. And I'm left with what? 4B. Minus followed by minus simply means minus times minus, which becomes plus what I have there, 3B, is equal to 26 minus 5 here gives 21. 4B plus 3B here is 7B is equal to 21. So getting my B here, I will simply divide both sides by the coefficient of B, which is 7. So when this cancel this, we simply can say B is equal to 3. So in order to get the other letter in these two equations, so what I'm going to do is to make a reference to any equation of my choice. Now, I'm still interested in equation 1. Any equation can be used, but as far as I'm concerned, it is equation 1 I want to use. In that case, I'm going to copy that equation 1. So my equation 1 states that A plus 2B is equal to 13. That is equation 1. Now in this new equation, the value of b I obtained there is what I will put anywhere I see b, right? So that now becomes a plus 2b. 2b normally, in as far as algebra is concerned, means 2 multiplied by b. So we are now going to treat it as 2 times what is the value of b we obtained. In what we have done so far, we can see that is 3. So that will be 2 multiplied by 3 is equal to what? 13. So here I say that a plus 6 is equal to what? 13. So getting a here, 6 will be sent to the other side of the equation. That is 630 minus what? 6. And we can see a in this case is equal to 7. So with this, I can summarize the whole thing which happened on the board by saying that therefore a is equal to 7 and b is equal to 3, and that also give the complete solution to the second question under our second example. So that is how far we can go today. So this is just under the introduction to this interesting topic. So in our upcoming sessions, so we are going to see how do we apply elimination method and how do we solve more advanced question as far as simultaneous equation is concerned. So on this note, I say to you, goodbye.